Hey guys, thanks for clicking on this video and welcome to episode 9 of my Arduino tutorials. Episode 9. We've come so far. Anyways, in today's video we'll be learning about the analogWrite command. It's one of the it's a command in the Arduino, so we'll just learn about that. I've already built my Arduino, so without much further ado, let's get straight into the video. Alright, you can only use the analogWrite command with a few pins. Not every digital pin can be used to send the analogWrite commands. You can use these pins which have this kind of wavy line. From 11, 10, 9, you can see they have this kind of wavy line. 6 has the wavy line, 5 has the wavy line, and then 3 also has the wavy line. That wavy line, if you look at the pulse width modulation side right here, it shows that those are the pins with the pulse width modulation feature. So I'll explain what pulse width modulation is. Now, the analogWrite command isn't using true analog signals. It's using the digital pins to send digital signals, but it's working with pulse width modulation. And what that is it's basically turning the LED off and on really quickly. It's sending high and low signals really quickly. It's at a high frequency, so your eyes might not be able to keep track. To you, the observer, it looks like it's either dimming or getting brighter. That's what it's using. So with pulse width modulation, you can do that, and we're using it with the analogWrite. It's not changing the voltage to make it go or to dim it or to make it brighter. It's just turning it off and on really quickly, so then it creates the illusion of it dimming or getting brighter. That's basically what's happening. Now, the analogWrite has an 8-bit range. 8 bits, that's 2 to the power of 8. So that's 256. 2 to the power 8 is 256. 256. So think of it this way. Imagine you had 256 boxes and then you were writing a number on a sheet of paper and putting it in each box. If you started from 0, the 256th box would have the number 255 rather than 256 because you started from 0. That's how it works. It's using 8 bits, but then it starts from 0 to 255. 0 being the lowest and 255 being the highest. 0 is basically off. That's the low. If you're using a digital write, you put it to low. That would be 0 in analogWrite. And the high would be 255. That's the highest. It uses those numbers as its range. That's the range of values. So you can dim it by just reducing the number. And you can make it brighter just by increasing the number. But the max is 255. That's the high. That's 100% duty cycle. That's 100% on. And they will be off 100% of the time. Somewhere in the middle will be 127. That would be 50%. I don't want to go into the details, man, but I hope you get the idea. It has that range of values you can use to dim your LED or whatever you're working with. Alright. So 256 different values, but it starts from 0. The highest is 255. So you can use any of those numbers when you're writing your code. Alright, to use the analogWrite command, you first need to set it up in the void setup. And we do that using the pin mode command. Remember this. We're connected to pin 11. Set it to output because we're working with an LED. Alright, and now I come down here to the void loop. And in the void loop, now we use the analogWrite command. analogWrite bracket pin 11. Remember that? Okay, we've already made a mistake. Remember guys, we need to always use variables rather than this. It just makes it easier if we want to change. Imagine I wanted to change the pin. I'd now have to change this and then come down here and change this. But with a variable, I could just change it once. Remember, so int, let me just call it pin. Pin 11. So let me make this pin. Which is 11, right? All right. So now, normally when we use the digital write, we put in high or low here. But then with the analog write, we can put in a value from 0 to 255, 0 to 255. Those 256 values, because it has that 8-bit range. So over here, I can put in something like, let me just put in something right in the middle, 2127, and come down. Let me put in a delay so that it has a certain amount of time. Also for the delay, I'm also going to use a variable. I'll call the variable wait. That's the time it's waiting for. Let's call it wait. Let me 1000. That's 1 second, right? 1000 milliseconds. So in the delay, I'll put wait here. I'm using a variable. The variable contains my 1000 milliseconds. Let me put another analog, right? So it will come on at this brightness for 1 second, and then let me make it pin 11. Okay, I made a variable, forgot about the variable I made pin. So, and over here, let me make it 255. So you can see the difference in brightness. 255. Delay, wait. All right. So then it comes on at this brightness, 127, goes off. Wait, no, it doesn't go off. It comes on for this with this brightness for 1 second, and then it changes to this brightness for another 1 second. Then it just keeps looping that over and over and over again. So let me upload my code and let you guys see it. Give me a sec. I come here, upload the code. All right, it's uploading. Yep. Now you see it. It's less bright than it's way brighter. It's less bright and way brighter, less bright and way brighter. It keeps changing like that. So you can see the difference in brightness. One is less, one is way more. Yeah, it's really cool. Well, now that I get the idea, I guess that's it. Don't forget to check the website for the notes. Link in description.